Alright guys, welcome back. Last few videos we've been talking about ions and ionic compounds, and in a nutshell we've talked about how ions are atoms that have lost or gained electrons and therefore have a charge. So they have either a positive charge or a negative charge, and you can see that. I've got a couple of tables here. You can see that in these tables that we've got here, the blue table. We've got some positive ions written here, and you can see hydrogen, sodium, silver, potassium, etc. And you can see that they all have a positive charge. Some have +1, some have +2, and there's even some with +3 and +4, etc. We've also got a title in the column here. We've got some negative, or in the table, we've got some negative ions as well. And there's, Cl minus, Br minus, F minus. So these guys are ions. They've either lost electrons, and those are all the ones that form positive ions. They're the metals. So they exist on the left-hand side of this periodic table. So you can sort of see anywhere here, all the way up to the jagged line, anything to the left of that, they're metals. And they always form positive ions. So they're really good at losing electrons to have those fall out of shells and be stable. And we've got our negative ions here. They exist up in the top little corner here to the right of the jagged line. And they're the nonmetals. They're really good at grabbing electrons, so that's why they become negative, because they grab those negative charges. They have extra negative charges. And they form those negative charges because they're very close to having a full outer shell. Okay, so they're only one or two away, and so they grab electrons from the metals. And so we have these ions that form. That's been covered in the previous videos. And we know that when those ions form, they then those ions have positive charges and negative charges, and they stick together. They form ionic bonds, right? So they form ionic bonds, and they're attracted because of their difference in charges. We know that positive things attract negative things, and they form ionic compounds. And ionic compounds are crystal structures, and they're made of lots of positive ions bonded with lots of negative ions. And we sort of looked at sodium chloride as our example. The purpose of this video is to have a practice of writing some formulae. So how do we write ionic formulae, beyond just the very simple ones? And so what I've done is, down here, I've just got a couple of examples that I want to run through with you. So these are the names of 6 different ionic compounds. You'll notice that they have a metal. So sodium, potassium, calcium, silver, magnesium, and iron, they're all metals. They have a metal and a non-metal. And these are ionic compounds. So they're made of a positive metal ion and a negative non-metal ion. So I'm going to show you today, or just practice, how we write these formulae. If we've given the name of an ionic compound, how do we write the formula for that? Okay, and I thought we'd start simple just because we've done it before. So we're going to start with sodium chloride. So we've got the name here, sodium chloride. So the simplest way to do this is we know that we've got 2 ions. We've got a sodium ion, which is Na, and the most important thing is that we go and find what the charge is on the sodium ion. So we can see here that the sodium ion is Na+. So we can come down here and write Na+. The previous video tells you why it's Na+, but we can write that nice and easily. The other cool little thing, just as a side note, if you want to try and start memorizing these charges, don't worry about that, because you can actually predict a lot of those off the periodic table. So if you can have a quick look here, this first group, they're called the alkyl metals. So we've already looked at those as groups. These red ones here, they're called the alkyl metals. And remember, they all have their group 1, which tells us that they all have 1 electron in their valence shell, which they're really good at losing. So the cool thing is, if they all lose 1 electron, they always form a +1 charge. So any element in that group 1 is actually always going to have +1, and you can look through the list and check me out. The next group over is the alkaline earth metals, and they have 2 valence electrons in their outer shell, which means they always lose 2 electrons and form ions with +2 charges, because they've lost 2 electrons. They have 2 extra protons than electrons once they lose them. So there's a really cool little pattern forming here, that the group number, particularly for the metals and the non-metals, tells you what charged ion they're likely to form. What will be their stable ion? What charge will it have? So we've got +1, +2. This column over here, even though it's 13, we treat it as group 3. We skip these guys. We can ignore them for now. And we go, okay, anything in this group, particularly aluminium is the most common one, will have a +3 charge. So if you've got access to your periodic table, you can actually look up a lot of these, and yeah, it's really easy. The other ones to remember here is the halogens. They will always form -1 charged ions, because they have 7 electrons and they need 8. So they're 1 short of a full outer shell. So they need to gain 1 electron to become like the noble gases. These guys here, group 6 or 16, need to gain 2 electrons. to have a full outer shell, so they form -2 charges. And these guys here, who are in group 5 or 15, they are 1, 2, 3 away, 3 electrons away from a full outer shell, so they need to gain 3 electrons. So they'll always form -3 charges. So there's a couple little shortcuts here that really help you when you're trying to write ions, and if you want to do it from scratch, really good little hint. But anyway, so we got sodium. So sodium's ion is Na+. We now got to find what a chloride ion is. Chloride, if we can remember, it's Cl-. Here he is. He's also over in the periodic table. There he is, -1. So we can write that down as well, Cl-. So we've got Na+ and Cl-, and they come together. So they come together to form our ionic compound. Now, the most important thing is when we write our ionic compound together, we take these charges and we make sure that they balance each other. So we have to have the same number of positive charges and negative charges in an ionic compound. Even though an ionic compound has positives and negatives, overall, that crystal has to have a balance of those charges. So there needs to be, if there is one positive charge like it is with the sodium, we've got one negative charge with chlorine or the chloride, then we need one of each to balance them out. So it actually forms sodium chloride, NaCl. That one should be nice and easy. Let's do one more. Potassium. So potassium is K+. And fluoride, if we go up and check our table again, we can see that fluoride is F-. He's also in that group 7, which means you can check as well. He's got a -1 charge. And so he's F-. And so we can write those ions down. So we write our metal, K+, and our non-metal, which is F-. And now we check. We have one positive charge here, and we have one negative charge here. So we can just write those two ions together, which is potassium fluoride. Right, number 3, calcium iodide. Now this guy gets a little bit trickier. We know that calcium, if we go up and have a look where calcium is, here's calcium. Now he's got a +2 charge because he's in group 2. So there he is. So he's missing 2 electrons. He's got 2 electrons in his outer shell, and he's happy to lose those. And if if someone takes 2 of his electrons, he forms his calcium 2+ ion. So Ca2+. So we write that in, Ca2+. Now who is he partnering with? He's partnering with an iodide ion. So we have to go back up to our table, find iodide. Remember, iodide is a halogen. There he is there in the periodic table, and has a 1- charge. So we write down I-. Now this it gets a little bit trickier because we've got an ion, a positive ion with 2 positives, and we've got a negative ion with 1 negative. So we don't actually, if we just write CaI, we don't actually balance our charges. We've got 2 positive charges and 1 negative. So the negatives don't quite cancel out the positives. So what do we need to do? I'm just going to move that over. We actually need to have an extra negative charge, because if you can see, we've got 2 positives and only 1 negative. We need to have a second negative charge. And so what I've done there is I've put a big 2 in front of that iodide ion. That means that we're going to have 2 of these iodide ions. All right, partner up with every one of the calcium in the crystal. So if we have 2 negative charges with every 1 calcium, we actually balance our charges. Okay, so we've got +2 here, plus 2 times -1, which is -2, and they will cancel each other out, and they will that makes our compound balanced and neutral overall. How do we show that on the right side where the compound is written? Well, if there's a big 2 here, that big 2 says we've got 2 iodide ions that are needed. What we do there is we put a little 2 down the bottom. That little 2 tells me that in the formula of calcium iodide, we have 1 calcium and 2 iodide ions, and that makes our crystal. That's our calcium iodide crystal. All right, let's try another example. So silver oxide. So silver is Ag+ from the table. Oxide is O2-. So we're going to write them out. Ag+ plus O2-. So again, we check our charges. We've got 1 positive charge here, and we've got 2 negatives here. So we haven't got enough positives. How many do we need to balance it out? Well, we need 2 of the silver ions to balance out the 2 negative charge here on the oxide. So we need to have 2 of the silver ions. So if we have 2 silver ions and 1 oxide, they balance their charges, and we end up getting silver, and then we have 2 of them, oxide. silver oxide. Just going to write the names in here just so you have them. Okay. Last two. Magnesium. Now magnesium is in group 2, so he's magnesium. He's in group 2, so it means he's a metal, and he forms 2+ ions whenever he gets the chance. Oxide is in that group 6. He's 2 away from a full outer shell. He's a non-metal, so he forms -2. You can check those up in the table if you want. So we write those down. Mg2+ ion plus an oxide ion, O2-. Now we write the formula for the compound. We've got 2 positive charges on the cation. We've got 2 negative charges on the anion. So they're balanced this time, aren't they? So there's no need to do any balancing or rearranging. This is called balancing because we've got the charges are already balanced. 2 positives and 2 negatives. So we can simply just write MgO, and that's called magnesium oxide. Now you'll notice that we are not writing the charges on this side. So we only ever write the charges, you know, when you get good at these, you can just do them in your head, but we never write the charges into the actual formula for an ionic compound. We always just write the ionic compound as the symbols, and a chemist will know that magnesium oxide contains magnesium ions and oxide ions. So we never write the charges in our ionic formulae. All right, the last one. Now I put this one in here because there's just one little trick with this guy. We've got ion 2. You'll see this is like Roman numerals. This is a 2. Now if you come back up to the table here, we can see that there's actually ion 2 and ion 3. There's actually 2 versions. It's like it has multiple personalities, ion. It can actually form ions, and we're not going to explain why, but it actually forms ions with a +2 charge and sometimes with a +3. So as a chemist, you've got to tell the person who's trying to write this formula which ion you are dealing with, and they've told us that they're dealing with the ion 2+ ion, so Fe2+. That 2 tells us it's the 2 version. If it was a 3, it would be the 3+ version. And we've got a bromide ion. Bromides, just so we can check, he's a halogen. There he is. So if he's a halogen, he's got a -1 charge. So we're going to write that Br negative, and you can put negative. You can put -1 if you wish. So we come over here and write Fe2+ plus Br-. Now we've got to make sure the charge is balanced before we write the final formula. We've got 2 positive charges and we got 1 negative charge, so we have to fix that. They're not balanced. Just going to move him over. So how many bromide ions do we need to balance this 2 positive charge? Well, we need 2. If we have 2 bromides, then we can form Fe Br(2). The little 2 tells me there's for every 1 Fe we have in this crystal, we have 2 bromide ions, and that balances our charges and makes it neutral. And that makes our, the names are over here, aren't I? Silly. Ion 2 bromide. All right, so there's some simple ionic formulae, so how we write. So we've got the ions and how we write the formula from those ions. The biggest thing from this lesson is to work out or to remember or to start to understand that we have to actually, when we write an ionic compound, the most important thing is that we know what the charges are on those compounds and that they need to balance. And the way that we balance them, I've sort of shown you in this video. All right, guys, hope that helps.